All right, so now we're starting to move into even weirder examples involving radicals. So here, again, this is a product rule problem because we're deriving a product of two sets of parentheses. And then we know eventually we're going to need to use the power rule to derive each of these radical things here, term by term. So with that in mind, we're going to have to change our radicals into fractional powers. So let's do that. Before we take derivatives, I'm going to carry this ddx around just so it indicates that we're going to take derivatives at some point. So we have 4. Okay, so radical x, square root of x. That's the same thing as x to the 1/2 power. The next one is minus third root of x. That's the same thing as x to the the 1/3 power. All right, then you have 2, x to the minus 2. Nothing changes there. No need to put that minus 2 in the denominator or anything like that because we want to use the product rule. So then we have a 5th root of x, so this becomes x to the 1/5 power. All right, so as a general bit of advice before we proceed is anytime you see radicals in calculus, turn it into a fractional power because odds are that's going to help you. Radicals are just there for presentation and showiness, but in general, the numerical powers are going to help you more often than the nice box powers. Or I mean the box shape, if you like. So now we can derive this. What's the first function? What's the second function? Purple and green, as always. So now we're going to derive this using the product rule. Derive the first one. So what we do is we take our fractional power, we bring it down in front, subtract 1 from the power. So we have 4 times 1/2 times x to the minus 1/2. And then we do the same thing with the second term. You bring your 1/3 down, so you have minus 1/3, x to the minus 2/3 when you subtract 1 from the exponent. Okay, so that derives the first. Then we leave the second one alone. Copy paste. Nothing changes. Nothing at all. There we go. And then we do the same thing over here. We're going to copy paste the first one. So we have 4x to the 1/2 minus x to the 1/3. And then we derive the second. So I'm going to move this down to the next line just so I don't end up squeezing into the edge of the screen. All right, so derive the second. This gives us, well, take your -2, you bring it down in front, so you have 2 times minus 2, x to the minus 3 when you subtract 1 from the exponent. Do the same thing here with this 1/5, bring that down, so you have minus 1/5, x to the minus 4/5. And I still ended up running into the edge of the screen. Sorry about that. All right, so now algebraically simplify, just arithmetic your coefficients, so at least it's somewhat pretty. So 4 times 1/2. So what's half of 4? 2. Then you have x to the minus 1/2. Then you have minus 1/3, x to the minus 2/3, times 2x to the minus 1/2 minus x to the 1/5. And I'll add on my next line because I'm going to run into the thing over on the right, plus 4x to the 1/2 minus x to the 1/3 for the third set of parentheses. And then the final set of parentheses, I have this 2 times minus 2, so it gives me minus 4, x to the minus 3, minus 1/5, x to the minus 4/5. Okay? And with that, I would say that this problem is done. Yes, you can transform your powers back into radicals, but again, that's just for show. It's nothing more than that. This answer is going to give you, this will give you full credit on any problem that you do.